Our next questions are from GATE 2014 process calculations for 2 marks. Actually, we'll solve 2 questions here. Question number 41. 2 elemental gas are reacting to form liquid in a steady state process as per reaction A plus B gives you C. The single pass conversion of the reaction is 20%, hence recycle is used. The product is separated completely in pure form. Note it down this. The flash feed has 49% A and B each along with 2 mole percent impurity. That means 49 mole percent A, 49 mole percent B. Right? And here 2 mole percent is impurities. The maximum allowable impurities in the recycle stream is 20 mole percent. The amount of purge stream per 100 moles of flash feed is. Let's start with the solution. This is the scenario of the question. They are saying that A plus B gives you C. This is the reaction, right? We are separating the pure product here, C. Here is only C, and A plus B and impurity are going here, right? We are doing the purge since continuously impurities, or we can say inert, is generated, right? So we can say we are doing a purge, right? Remember one thing, they are saying that there is a pure is C and here will be A plus B and I, right? So if recycle is, since they have given the maximum allowable impurities in the recycle stream is 20 mole percent only. If it is 20 mole percent, remember one thing, whenever there is a splitting of the stream, then composition will remain same, right? So composition will be same in recycle. If in recycle composition of inert is 20%, then it should be 20% in purge stream also, right? Remember this thing. If you know all these things, we have F is equal to 100 mole and we have 49 mole A, 49 mole B and 2 mole I in this, right? So we don't need to do anything. We will apply the impurity balance. We will apply the material balance on the impurity I on this, right? On this. So we just this question will be solved in a single line. You can see here, inert in should be equal to inert out at steady state, right? So you can see here inert is equal to 2 mole I. So P into 0.2, inert out should be P into 0.2 since it is in 20% in P. So from this we are getting P is equal to 10 mole. This is the final answer, right? Our next question is, carbon monoxide is burned in the presence of 200% excess pure oxygen and the flame temperature achieved is 2298 Kelvin. The inlet stream are at 25 degrees centigrade. The standard heat of formation at 25 degrees centigrade of CO and CO2 are this and this respectively. The heat capacities of the components are, we have given this, where T is the temperature in Kelvin, heat loss per mole of CO burnt is. So let's start with the solution. See here, this should be the reaction. CO plus half O2 gives you CO2. Since we are supplying the excess oxygen, so this will produce only CO2, right? And we are considering here 1 mole basis of CO, and theoretical oxygen required from this stoichiometry, we can say it is 0.5 mole only. We have given excess oxygen supplied is 200%. So amount of oxygen supplied will be 0.5 plus 0.5 into 2. 200 is 2, right? 200% means it is 2, right? 200 divided by 100, it will be 2. 0.5 into 2, so it will be 1.5 mole. 1.5 mole oxygen we are supplying and 0.5 mole is reacting. So that means oxygen unreacted that will be coming out, right, is equal to 1.5 minus 1.5 mole minus 0.5 mole is equal to 1 mole, right? Now you can see here from this 1 mole CO producing 1 mole CO2, and in exit stream we are getting 1 mole oxygen also, that was in excess, right? Now heat in plus heat generated is equal to heat out plus heat loss. There is no problem, right? Heat in plus heat generated and we know that heat in should be 0. Heat in will be 0. Why? Since we are supplying the reactant is at 25 degrees centigrade and reaction is happening only at 25 degrees centigrade, that means it is already at a reference temperature, so there is no heat in the question. The standard heat of formation at 25 degrees centigrade, that means reaction will happen at 25 degrees centigrade, right? And they have given one more thing, the inlet stream are at 25 degrees centigrade, so heat in or heat out, heat in should be 0, heat in will be 0, there is no problem with this, right? But heat out, but the flame temperature we are getting 2298, output we are getting the output stream temperature 2298 Kelvin, that is more than the reaction temperature 25 degrees centigrade, right? So heat in will be 0, again we are getting now heat generated is equal to heat out plus heat loss, since it will be 0. Now we will see here Q of CO2. Now we need to calculate first heat out. Heat out, we have two streams, we have two components CO2 and O2 in the exit stream only, right? In the exit stream we have two components, carbon dioxide and oxygen. So first we need to calculate the heat first we need to calculate the heat out due to CO2. So what we will do, Q CO2 is equal to N of CO2, moles of CO2 from 298 Kelvin, since reaction is happening at 298 Kelvin, that is 25 degrees centigrade, and exit temperature is 2298 Kelvin, and Cp of CO2 dt, and Cp CO2 we have given in the question, that is 25 plus 0.042 T, it should be equal to, right? After solving we are getting Q CO2 is equal to 159.032 kilojoule, and we know that Q CO2 moles of CO2 is 1 mole, I have already told you. Similarly QO2 1 mole into, and we have given Cp of O2 we have given, that is 25 plus 0.014 T. After solving we will get 86.344 kilojoule. Now we will add these two, heat out should be 159.032 due to the CO2, due to oxygen, from this we are getting 245.376 kilojoule. Now heat generated, here what will be the heat generated? Here heat generated, or we can say heat of reaction, will be equals to 1 mole into this. Heat of reaction will be calculated by the heat of formation, and it will be calculated as for CO2 we have given heat of formation of CO2 is 390 kilojoule per mole. We have given that minus 390, CO2 is minus 390 kilojoule per mole. For CO we have minus 110 kilojoule per mole. We will calculate the heat of reaction. What we will do, heat of formation of CO2 into mole minus heat of formation of the reactant, and remember this heat of formation of oxygen will be 0, so there is no problem with oxygen. So we just do one thing, you can see here, this is for CO2 minus 1 mole into this minus 110 kilojoule per mole. From this we get heat of reaction is minus 280 kilojoule, right? Now we will put all the values. Heat generated is equal to heat out plus heat loss, and it is 280 kilojoule is equal to 245.376 kilojoule plus heat loss, so heat loss is 34.624 kilojoule. And remember one thing, negative sign only showing that heat is liberated, there is no problem. If we are already saying that heat is generated, so we will put 280 kilojoule, there is no problem with this, right? So heat loss is equal to 34.624 kilojoule. Actually it should be kilojoule per mole, since it should be kilojoule per mole of CO, since in the starting of calculation I have told you that I have taken that at 1 mole CO as a basis, right? So the final answer is 34.624 kilojoule. This is the final answer. So thank you. Please make sure to like, share and subscribe my channel. Thank you.